This is part 2 of the wood projection tutorial. First thing I need to do is make a simple correction. I forgot to get the square root of our circular function here. So I'm going to go ahead and add that. And I wanted to comment this section right here. Now for this video we're going to do something a little different than wood. We are going to make a spun metal bowl. Now this is based off of a bowl that I made in Maya. Very simple. Here's the wireframe for it. It's not particularly detailed or anything. So we're going to need to duplicate this. Let's drag a new one in. It will create a new material. And apply it to our mesh. Now we're going to start with an almost white base color. Which is 0.69 all the way through. We're going to make it completely metallic. And add a roughness of 0.4 to start with. Now we're going to convert these all to parameters. Let's go ahead and make a material instance out of this and apply that to our bowl instead. So that way when we change the roughness of it, we can get a view of that in real time. So go to 0.25. And we're going to need our circular projection node. Actually, we need to make another change to that real quick. Right now it's only outputting a diffuse. We're going to duplicate this so that it will also calculate normal at the same time. Label these properly. it's not updating. Let's drag another one in. There we go. To make this work, I went and made a couple Perlin noise textures. This is just a simple Perlin noise, and I ran it through a bitmap to material and made a normal map for it. So I'm going to go ahead and drag both of those in. We'll pipe this to the normal. So it has to be a texture object. Actually, we don't even need the noise texture, we just need the normal. We need to change the texture scale. We'll make that 100. I'll put that to normal. Faults to 0.5. Oh, let's add a Boolean. Make this a little easier to see. Let's use our bowl mesh in the material editor. There we go. Starting to look like a spun metal bowl. But you'll notice that there are some pretty weird artifacts right here where it's obvious that the vertices are. And the reason for that, because if you look at the finished one, we don't have that issue. The reason for that is the calculations are based on the vertex shader. So in order to make this look better, we have to essentially give it more vertices to work with. So what we're going to do is we're going to tessellate this mesh. I'm going to turn on tessellation using PN triangles and crack-free displacement. We're going to add a tessellation, we're going to add a scalar parameter to our tessellation multiplier. Name it testmult. And we'll default it to 2 for now. And you can see that that fixed the issue. Now the problem comes when you're going to have many of these in your scene at one time. It's tessellation is fairly expensive, so we only want to do it when we're up close to the mesh when it's really critical. So what we're going to do is we're going to set up the tessellation to be based on the camera distance. So what we're going to do is we're going to make another material function called distance-based tessellation. And what it does is we have 2 inputs, a minimum distance and a maximum distance, which should be scalar. Okay. We have camera position input data and object position input data, and we put them into a distance node, subtract our minimum distance from the distance between our camera and the object, clamp that value between our minimum and maximum distance, and divide that by the difference between our min and max difference. Get the absolute value of that, invert it, and return it. So with that, we can drag this node in here. Multiply the result of the function by our test mult parameter. And we will need 2 more scalar parameters for min and max distance. And we'll set these to 100 and 1000. So we compile that, and if we put it on wireframe, you can see where we have a highly tessellated mesh, and as we back away from it, it doesn't tessellate so much. We can actually change the max distance to, let's say, 500 to really make it visible. So you can see the difference. 500 is probably a little too close. So I'll put that back to 1000. And it's almost imperceivable. Now we need to convert our scale to a parameter. And there's one more thing I want to do. Sometimes the normals from this can be a little strong, so I want to basically be able to turn it into a smooth bowl whenever I want to. So I'm going to need a linear interpolate node. We're going to input another parameter. We're going to call it normal intensity. And we're going to clamp that from 0 to 1. And the default value on the normal intensity should be 1. It should default to having the rings in it. I'll pipe our normal to here. To hook that up to the lerp node. Okay, so we have our normal intensity. bring it down to 0, doesn't really give us the effect that we want. So what we're going to do is we're going to add in a vector 3, and we're going to use this as a blank normal map. Leave the red channel at 0, green channel at 0, and put the blue channel at 1. So now we can interpolate between a smooth ball and one with very defined rings. In the next video, we're going to get into how we make some of the crazier wood grain effects, and we're also going to deal with the direction that the wood is being projected from. We don't always want it going straight up and down through the wood block like this. So, see you next time.